I'm actually really happy to be here today because Luke and Ryan really kicked my talk off well this morning by talking about some of the business impacts of what's going on. And the title of this is really about operations, but if you're going to do operations right, you have to be thinking about the business side of things and about who you're collaborating with to help deliver business value, deliver applications. And so a lot of this is going to be about not just what's happening in ops, but the kinds of things that are happening in nearby spaces like architecture, like even marketing, because if you're doing DevOps right, you're doing it with functionally oriented teams, right? Sort of surgical teams, people with operations, developers, QA, security, all in the same room, collaborating closely together to deliver a product, rather than what I run into incredibly frequently is you'll have the development group, let's say in one campus, and the operations group 1,000 miles away somewhere else. That makes doing DevOps awfully difficult. So we're going to talk today about some of these really new emerging technologies and how they're going to change the way we're building software and delivering software and supporting our customers. And the two that I can't go to a conference anymore, and I go to a lot of conferences. This is the second one I've been at this week, just to give you a sense of how much I travel. And every single conference I've gone to for the past year and a half now has some kind of a whale logo somewhere in the keynotes. And more recently, microservices has gotten really popular. Just a couple of quick stats on what's been going on with microservices. So there's a pretty popular developer conference called GlueCon. Happens every May or so in the Denver area. And last year at GlueCon, there were 0 talks on microservices. This year, there were 12. Another example, I know one of the conference chairs for OSCON pretty well, Sarah Novotny. She just passed it on. And she gave me some stats on their proposals. And this is the biggest open source conference in the country, if not the world. And at OSCON, they had one proposal about microservices last year, and this year they had 30. So this is something that's come out of nowhere very, very quickly, a lot like Docker, and is really changing the way that people are thinking about how they build and how they support new applications. And thinking about also how do you migrate those old ones, which is a topic that we don't have enough time to get into, but I could talk to you about it for a day at least. So in our time, we're going to try and get through a lot of stuff. I'll try not to move too fast because it's more important that you remember a few things than that you hear about 500 of them. So roughly, we're going to go through, at a very high level, what the IT landscape looks like today, what kinds of things are changing. We're going to run through not just what DevOps is, but how that has changed over the past 5 to 7 years since it became a term, how that's becoming a much higher level, and we're thinking a lot more about the business impacts of it than just about getting developers and operations talking to each other. We're going to talk some about what containers are about very briefly, and then how they're changing the way we're building and delivering apps. We're going to get into this microservices idea, talk about what that's all about, and then finally discuss some real-world examples of people using containers and microservices in action. And just to kick this off, talking about sort of the very high-level business aspects, we do a lot of surveys. We actually have a survey panel now of about like 20,000 IT decision makers that we go out and survey on a quarterly basis, ask them how things are changing, what they're doing in areas like cloud, storage, DevOps, and so on. And in almost every survey, what we've seen starting to change more and more is that IT isn't just about cost center anymore, right? This is the kind of conversation we've been having for a long time. We've seen the rise of things like chief digital officers because some traditional IT shops can't get that mindset change of we have to contribute to business value. We have to be working and collaborating very closely with the rest of the business. And that's where the chief digital officer came from. It's from IT shops that haven't been paying attention to what's going on and haven't been keeping up. And so we see that growing. We see IT focusing, not just on lower costs, but the ideas of really increasing agility more than anything else. I mean, we've been hearing this from so-called unicorns like Netflix for years, but it's really starting to get out there more and more about collaborating with the business, about IT becoming more like a service provider, right? IT delivering services to its internal customers because, as you heard Luke talking about some of the high-level trends like consumerization of IT, like shadow IT, everybody's got a choice now, right? They no longer have to go through central IT in many cases. Maybe they're supposed to, but that doesn't mean they do. And so that puts the imperative on you to figure out how do you get them to come back? Because what I think will start happening over the next few years is a lot of that IT budget will become optional coming in from lines of business, and they might choose to take that money elsewhere. And then what happens? That's an existential threat. That's not just a concern about chief digital officers and things like that. And so it's really about, how do you increase that agility while at the same time doing what IT is well known for, which is reducing the risk, right? Because every company takes enough risks with the business it's in. There's no point in taking additional unneeded risks on a technology stack. And so one thing that I think a lot of people don't appreciate about some of the newer techniques for architecture and delivery is that almost every single one of them dramatically lowers the impact of the risk. You go through things like DevOps as a whole, like microservices, like continuous delivery, like rolling updates. Every single one of those things makes sure that when code does break, it affects a very small audience and it's very easy to fix. And we'll get back to that later on in the talk. So here's just some more survey data. I apologize that it's a little bit hard to read. Like I was saying, AV is unsolved. And the basic idea, though, is what we see when we go out and ask people who are actually doing DevOps in enterprises. We hear that they're all getting demands from their lines of business about, we need faster, we need speed, we need you to serve us better. And that goes across the board. The industry breakdown is roughly what you would expect, in that you've got some examples like e-commerce and entertainment and gaming sort of forward-leaning in many cases, whereas you've got some more traditional industries like manufacturing farther back. But the vertical breakdown isn't the important part. The important part is we're hearing this across the board, and something like 63% of all industries are saying, we need to go faster. And the question is, how do you do it? The final, I think, major trend I want to talk about is that over the past 10 years or so, with the advent of cloud, with the advent of open source becoming sort of the default, that's given developers, DevOps engineers, and IT ops a lot more empowerment in the kinds of technologies that get used, right? This is how Linux basically won in the data center. This is how MySQL became one of the most popular databases out there, because it got implemented at the low levels, and developers built apps with it, and then they went to the director or the CIO and they said, hey, we built this application using MySQL. Should we flip it over to Oracle right now? And if you ever think about risk, you're like, no, not a chance. We're never going to do that. And so the way technology adoption has changed, and that's really influencing the way these things get into your organizations, right? Because you're seeing things come in and you don't have the same kind of power to necessarily dictate choices, even if you do still control the budget. And so this is just some more survey data. I'm kind of go through it a little bit quickly because I want to really get into some of the meat. But we're seeing that when we ask our panelists, we got about 60% of them doing very traditional IT today, right, for app dev workloads in particular. They're on-prem, not cloud. They're in many cases virtualized. In a reasonable number of cases, they're automated, but it's still a very traditional world. But they think in the next 2 years, about a third of that is going to be gone. It's going to all be going to cloud of one sort or another, whether it's public cloud, private cloud, hosted cloud, what have you. Everybody's trying to figure out how do they get this out there. And the challenge is, in many cases, cloud is not easy to do, and it's hard to figure out what is the role of IT in a world where there's no racking and stacking. And so the last thing I want to talk about here is what is getting built on top of the services that IT is delivering. And this is of concern because if you're supporting microservices versus supporting a big monolith, it dramatically changes the way things look for you, dramatically changes the way debugging works, dramatically changes the way support works when there's a lot more distributed applications out there, like Luke and Ryan were talking about this morning with Puppet Orchestrator, right? Of the network is suddenly a much more important problem, not just across applications, but within every single application. But the problem with the new stack is it's not as simple as it used to be with languages, with databases, with frameworks, anything. Everything is so fragmented now. It used to be, I took a look through open source software over the past 20 years or so, and it used to be about 1995, you could, let's say something like 80% of all open source projects were written in one of 3 languages. That was it. And now if you want to figure out what are 80% of all open source projects written in that are started today, it's more like 10 languages, right? It's not as easy as it used to be just to say like, all right, we got C, C++, Java, now we're good, right? It's like, well, no, you've got that and Python, and you've got Rails apps, and you're starting to have Go apps, and you've got Node. I mean, there's no easy answer anymore to what gets supported. And with what I was talking about with bottom-up adoption, a lot of these apps are delivered to many IT shops as sort of a fait accompli, right? Like, let's say, here it is, you got to run it, now have fun. I am curious, though, how many of you are leading, let's say, one team in IT? Reasonable number. How about a group? Or larger? Anybody who's here to learn about leadership and not running in a team yet? All right, we've got a forward thinker. Thank you. I knew there had to be somebody thinking about their future here who wanted to move up. And so that's sort of the broad landscape and what's changing. I want to talk a little bit about DevOps. How many of you think you know what DevOps is? Not so many. Wow, this is great. Of those who had your hands up, how many could define it for me? We got 1, 2, 3. Excellent. The problem is everybody you talk to has a little bit different definition. It's a lot like, what is cloud? Or the new question, what is microservices? There is no single answer anymore. So just so we get on the same page, I want to talk through mine. I think the most important part of it is really thinking about, what's the point of all of this, right? Because it's just like a lot of shops have been doing waterfall. They're trying to move to Agile or Scrum or sort of pick your methodology. And the thing that happens is they get so tied up in the process that they forget about what the point of it was. They're sitting there saying, like, okay, we've got to do ITIL, we've got to do Agile, we've got this Agile manifesto, we got to follow it point by point, and we found a vendor that'll sell us Agile, and it's going to be great. And you're sitting there doing your stand-ups, getting all tied up in this stuff, and you forget that the point here is to deliver value to your customers, whether that's internal or external. The point isn't to be an Agile class 4 organization. Nobody cares. And so the real value of DevOps is not about just developers and operations working together more closely. It's moving beyond that and thinking about how can you iterate more quickly between the business and what they're delivering to their customers. And that's what DevOps really gives you, is tying that whole chain together so that you can continuously deliver not just a thing, but the right thing. I'm not sure if you've heard, there's a guy named Jez Humble, wrote a book on continuous delivery. And there's a phrase he loves to use that is water, scrum, fail, right? Where you've got Agile development happening, going through 2-week cycles, and building these 2-week cycles on and on and on for 6 months. And then they deliver the application to IT. And they say, we've built it, it's done. And the problem is the market's changed since 6 months ago. Your competitors have come out with new products. It's no longer the same thing it used to be. And so that's why IT being part of the process is super important. I'm curious, how many of you are doing DevOps today? A few? How many of you want to be? Most of you? Excellent. Well, you're in the right place. So when I think about DevOps, right, that's the overarching picture, right, which is sort of pushing Agile development all the way through to production so you can deliver the right thing to your customers more quickly. But that really breaks down for me into 3 pillars. And like I said, everybody you talk to will have a slightly different definition. This one is mine. In that you've got culture, automation, and measurement. Some people add sharing onto that. I think that if you're doing culture right, that's a natural aspect of the cultural side of things. And so culture is really about, first, breaking down the silos, right? Like I was talking about earlier, building things into kind of a functional organization. Are any of you doing this today? A few? Oh, excellent. I love it. The culture side is always the hardest side. And this is the side that requires buy-in from people like you. Because it's easy to implement technologies on a team basis. It's a lot harder to pull in developers and ops from all over the place and get them really working together without the kind of executive buy-in that you can provide. So this is a really, really critical aspect of all of it. Because are you familiar with Conway's Law? Right? That organizations will build software that resembles the structure of the organization, right? Because the natural interfaces will be between different teams and between different groups. It's harder to collaborate across different groups. And that goes both ways, in that if you change the structure of your organization, the structure of your software will change to fit it. If you get the right tools in place, they will help you make the cultural change. So you kind of have to do the 2 things in lockstep of you're going to do this cultural shift, you're going to reorganize, you're going to talk a lot more about collaboration both internally and externally, but you're also going to change your tool set such that it encourages you to collaborate. Right? Like here at PuppetConf, we've got Slack for the conference. And that's a perfect example of a tool that can encourage that kind of collaboration, right? Even for distributed teams. Even if you're, I was working with an insurance company a year or two ago, and they had a few hundred dev folks somewhere in the middle of the country, a few hundred ops folks on the coast. Makes collaboration hard, like I said, but modern tools, modern collaboration software like Slack, like HipChat, take your pick, makes it a lot easier. So that's the cultural side of things. The second piece, you're all familiar with the pets versus cattle metaphor? Have you come across that? Excellent. So the second piece is automation, right? And automation is just changing the way you think about what a server is, and whether a server is a unique snowflake or whether it's something that's really just a fleet, and the logical unit is a cluster or even a data center. And that's the way we're really changing the way we think about these things, right? There's no more such thing as like naming your servers after your favorite Star Trek ships or characters, or your favorite animals or what have you. And automation comes in really two flavors, right? One of them is the infrastructure side, and one of them is about application delivery. I'm showing this picture of a factory in the background just to indicate the ways manufacturing is changing, which very closely resemble the way that IT is changing as people move to DevOps. So infrastructure as code. You're all here. I'm assuming you're familiar with the idea. That's the whole point of all of this, right? Or at least that's what we're doing. That's not the point, right? The point is to be able to deliver more value to the business. How we do that is automation. Automation at the server level is one side of it, right? But that's really, if we talk about what kinds of demands IT is hearing in general, we hear about agility, we hear about cost savings. This is typically a lot more of the cost saving side of things. How do we be more efficient? We can't get more budget to hire new people, but we have to do more things. And so we have to figure out how do we scale out the way we manage servers such that that one admin can, instead of maintaining 100 servers, can maintain 1,000 or even 10,000. Talking to modern cloud providers today, 10,000 tends to be the number they're aiming for, which you're not going to do in a world of pets. You have to be in a cattle world. One story I really love about infrastructure as code is this example of Knight Capital. Has anybody come across this story before? So, excellent. So Knight Capital was a high-frequency trading firm, and I believe it was back in 2012. They lost $500 million in the course of about 45 minutes. And how did that happen? Well, when this kind of thing happens, it actually changes the entire market, right? Because they're high-frequency trading. They're doing all kinds of buying and selling on a second-level basis. And so when their software goes wrong, it screws everything up, and there's governmental investigations that go into it. And what came out of this investigation was very interesting, in that they had 8 servers that were running their core trading application in production. And over the course of the investigation, they found out that how was the software getting deployed? Turns out it was getting deployed by hand, just manually. Admins just FTPing the code up. And what ended up happening was, due to the lack of automation and due to the lack of collaboration between development and operations teams, what happened was the development team repurposed a flag that had been used for something else a few years back. They said, oh, that feature name fits what we want it to do, and so we'll just reuse it because we've already got it there. So they did this thing, got deployed to, like I said, 7 out of these 8 servers. The 8th server started doing pretty weird stuff when they turned the flag on, as you can imagine, doing something that was completely wrong from 10 years ago. And as they were frantically trying to debug this problem, turning servers on, turning them off, rolling things back, rolling them forward, they couldn't figure out what was happening. By the time they debugged it, it was 45 minutes later, and they were $500 million in the hole. And had they used an automated deploy process, had they treated their servers as cattle rather than pets, this would not have happened. Now, if you read the SEC investigation, it won't go that far because they're not technologists. They'll start talking about processes and about you should have everything documented. But if you take an infrastructure as code approach to app delivery, it's self-documenting, it's self-automating. You don't need to have this big written process for what goes on if your code does it for you. And this is just a very brief slide I want to show you because a lot of people start talking about things like DevOps and continuous delivery and continuous integration, and it's not always clear how they all fit together. This is a really nice diagram that when you're trying to explain this to other people in your orgs, you can say like, all right, here's where things fit in, right? If you're coming from the app dev side, a lot of times step 1 is CI, right? You roll out Jenkins, you start using Travis CI, take your pick of CI servers, and you go from there. Whereas, what this doesn't show is what happens if you're coming from the infrastructure side and you decide to do DevOps that way in, which typically starts from the opposite perspective, right? We talked about two sides of automation. One of them is app delivery, one of them is server automation. And the infrastructure as code approach, using tools like Puppet, tends to be the IT-driven approach. And so this is a good picture of what the opposite side of it looks at, what the development teams are thinking when they come into DevOps. And frankly, what you should be thinking when you're coming into DevOps and talking to them about it, because like I said, it's all about business value. And the closer you can get to the applications that are getting built, that are getting delivered, the closer you are to that business value. Now the third pillar is monitoring, or actually it's measurement, and monitoring is one piece of that measurement. And I'm not going to spend a ton of time digging into this, but I do want to talk about this transition that's been happening in monitoring over the past few years. Traditionally, you're using some big enterprise, let's say a big 4, big 5 tool, from pick your choice of vendors with over 100,000 employees. Over the past 15 years, a lot of people started moving to something like Nagios instead. But even that, people started to get pretty fed up with the user experience. It was difficult to build plugins, difficult to make modifications, didn't support, in many cases, the kind of transient environments that we now live in. That's been one of the biggest challenges with the automation and with measurement as a whole is we were already in this cloudy world. Servers are appearing and disappearing inside of a few minutes. The next step is moving to containers and microservices. They're going to be appearing and disappearing in seconds. If your monitoring infrastructure can't cope with that, if your automation infrastructure can't cope with that, you're going to be in trouble. And so what changed was this new generation of monitoring frameworks that could handle that kind of transience that's happening now, right? Because DevOps, in all its aspects, is really a prerequisite for cloud, right? If you forklift your pets over to cloud, all you're doing is making things worse, because cloud fails more often. It's not any better for a single server basis. You have to re-architect everything, and you have to re-architect the underlying infrastructure too, which is why we're talking about monitoring. And so we started to see this sort of resurgence of UX in monitoring, and this addition of much more ability to handle transients. And one really good example of this is if you take a look at, let's say the logos toward the top left of that, you can see that there weren't a lot of designers involved in the process. But that's changed, right? And the logo really in many ways reflects the spirit of the application and what they're all about. And with newer tools like a Logstash, like a Sensu, like a Splunk, like a Graylog, Kibana, take your pick. I don't know if you've seen them, but they are beautiful. They are so much better than those sort of pixelated things back from 1995. And so those, when I think about DevOps, those are really the three pillars that I think about, and that's how you do it right. And now I want to get into how things are changing even more recently than that. All right, how many of you are familiar with containers? Excellent. So we're going to pretty much skip past this quick explanation. But what I do want to talk about is how they tie into DevOps, how they tie into app dev, and how that's changing. Now we've seen a lot of automation. We just talked about automation at the server level. We talked about automation at the fleet level. We talked about automation at the app delivery level. And what's been happening over the past, let's say, 5 to 6 years is automation around the VM, right? With tools like Vagrant, tools like Packer more recently. HashiCorp just came out with a replacement for Vagrant called Auto just last week that handles deploys as well as the automation aspect of just the VM itself sitting on a developer box. And the next iteration of that is Docker. So containers, not a new idea. They've been around for 15 years on Linux alone, and then we can get into debates on who really came up with the containers, right? Was it BSD with Trails? Was it Solaris Zones? Maybe it was IBM mainframes. They're all doing some kind of containerization. But what's changed really is not the idea of containers. What's changed is the barrier to entry. Docker made it way easier to use containers compared to doing things with LXC and cgroups. And they got the market timing right. Because what's happening right now, we're moving to this cloudy world, we're moving to this DevOps world. If you can support that with lightweight automation that gives you parity between your development environment and your production environment, which is one of the core tenets behind that automation that you do during app delivery and doing infrastructure as code, that puts you in a very interesting place. And so they got the market timing exactly right. And Docker, since it was open sourced about 2.5 years ago, is perhaps one of the 2 or maybe 3 fastest growing technologies I've ever seen. Fastest growing technologies I've even ever read about. It's amazing how fast it took off. And one of the ways it ties into DevOps isn't just containers are fun and they're lightweight and they're small and that's cool. But really, you can also automate how they're created using something called a Docker file, which is really just basically a bash script. And that's where you start to think like, all right, are bash scripts really the way forward for deployment? It feels kind of like a step back for me now. I just finished automating everything, and now I'm just going to write a bash script and hope everything works out. And one of the things I've done for a long time now is work on a Linux distro, and so I'm very passionate about package management. And the lack of that in Docker just kills me. And so, even in a Dockerized, containerized world, there is absolutely a very important role for automation for configuration management. The role of it is changing a little bit, though, because you're familiar with immutable infrastructure? Have you come across this term? Yeah, some of you? It's the idea that basically you bake an image once, you roll it out and deploy it, and you don't maintain it at runtime at all. When there's a change to be made, you roll out an entirely new image from scratch. Again, another thing that's only possible if you're using automation, especially at the kind of scale we're talking about here. There's no way you can have individual admins building gold masters, tweaking things by hand, whether it's Linux or whether it's Windows, in the kind of scale we're talking about. And so this immutable infrastructure idea is really one that Docker and tools like Vagrant and Packer and Auto support very well. But the problem is, well, how do you set up those systems reliably? How do you control them as a fleet? And that's where things like configuration management come into it. Right? I see the future of configuration management in many cases will be one of continuing to maintain runtime for your current approach to IT, and for this new immutable infrastructure approach, it's going to play a very important role in baking those images in a reliable way, and in being able to deploy them in a reliable way. Right? One of the things that Luke and Ryan were talking about this morning was dependencies. Right? As we move to a containerized world, we move to a much more distributed systems world, and you've got to be able to deploy things in the right order. Dependency management is a very hard problem. And it's one that there is zero. I was just at the AWS conference earlier this week, and a phrase they love to use is undifferentiated heavy lifting. Right? There is zero value in you building your own dependency management. Right? You're here because you work for a company that has a business model, and that business model is not doing dependency management for its servers. And so it makes a lot of sense to outsource that to somebody who specializes in it. And now, on top of containers, we've got this whole ecosystem emerging, all kinds of different things. One thing in particular I do want to touch on is container native operating systems, because they tie in very well into this new world of thinking about what does a Linux system or what does a Windows system now look like? It really looks like just enough operating system to start up your container environment, which is where all the applications are going to live. And so we've got an entire new set of distributions from a variety of different providers. Whether it's startups like CoreOS or Ubuntu's got one, Red Hat's got one called Atomic. There's another startup called Rancher that has one called Rancher OS. I didn't put that on the slide. And even in Windows land, right? DevOps is now a thing in Windows, and not just DevOps, but a very modern view of it, right? And it started with PowerShell, came up to defined state configuration, and now we've got this new idea of automation and of cloud native operating systems in Windows as well. And so the thing that I find great about that is, for a long time, Windows has been really left behind in this whole transformation. And most IT shops have very heterogeneous environments. You've got some Linux, you've got some Windows, you've got a little bit of everything. And being able to take the same philosophy to all of them, even if you're not using the same tools, is really going to be invaluable. And so here's a little bit of data I just wanted to show you on the popularity of Docker. So I was talking about how fast growing it was. So I went over to Stack Overflow, pretty popular discussion forum for developers, and did some data mining on it. Looked at all the different kinds of container-related frameworks over the past, let's say, 5 years. And what you can see is that purple line, none of the others matter. Just ignore all of them. The purple line is Docker. Everything else was kind of sitting along. Containers weren't very interesting. Docker came along and suddenly it exploded. I mean, you're talking going from a level of almost 0 to one of 600 posts per month. I can't even put a percentage on that kind of growth rate, but it's pretty crazy. Although the thing that's happening now is, again, going back to that pets versus cattle metaphor, right? That's coming to this container world too. We have to figure out how do we manage, how do we orchestrate those containers. And in some cases that's going to be with configuration management, the same kind that you deploy to other servers. In some cases, there's sort of new startups, new software popping up to try and just focus on containers. It's always hard to say which one's going to win, but the pragmatic view is if you've got a tool that you're already using, just keep using it. People ask me for recommendations all the time, and I say, like, what's your current IT environment look like? Why would you add another tool if you've got one that can already do the job? But it's not just with developers that Docker's popular. So earlier on, I mentioned one of those big surveys we do. We ran one earlier this year, asked about 1,000 people about containers, and it was astonishing to me how fast they've gotten, not just into developers' hands, but into the enterprise and into applications that are deployed. We saw, looking across things that were at least at the pilot stage, we saw more than 20% of the enterprises we asked had gotten to at least the pilot stage, and half of those had deployed to production in some form or another. Which, considering that they're just 2 years old, Docker is just 2 years old, that's astonishingly fast that it's getting into production. The only thing that I've seen anytime recently like this is Spark, which is a whole other conversation. But it is worth pointing out that this is something that's not just a toy anymore. It's something that's getting into the enterprise. And something I found really interesting looking at that kind of 10% number in prod is it very closely resembles how IT shops think of themselves. Whether they think of themselves as early adopters or whether they think of themselves as we heard from Nate this morning in the keynote, as sort of leading edge adopters, right? Waiting for the bleeding to get past, but then picking it up as soon as they can. And so I'm thinking that 50% of people, 47.8% of people, are just about to reach containers. And so there's something that you should definitely be thinking about. Where's that going to fit into your world? Because just like the bottom-up adoption that's happening with other technologies, the same thing is going to happen with containers. People are going to be throwing them at you and saying, like, have fun with this. I've got this app that deploys 1,000 containers, now it's your job. And so we talked earlier on about fragmentation. We talked about DevOps. We talked about containers. What happens when you bring all of this together? And that's where we come to microservices. Because if you think about a world, software development now is returning to a very Unix-like philosophy of one tool, one job. And if you think about that world where you've got 10 different popular languages, you've got 10 different frameworks within each language that are pretty popular. You look at JavaScript, for example, there's a different popular framework every week. I could have a full-time job just doing that. And you look at databases, right? People are oftentimes doing 3 or 5 different databases in one application now, right? They'll have one for relational, one for key value, one for graph maybe, one for objects. I mean, it's crazy the way things are changing. And what does that mean for how they build and deploy the apps? Well, that fragmentation means they're trying to segment things off into separate services so that every service can use the right set of tools for it. And that's where we end up with something like microservices. And containers are going to be, in many cases, the way those are deployed, because once you get a lot of them, and in the sort of cloud-native world, everything is a cluster, right? It's not just a single VM, not just a single container. The only way to get that to work well at scale is to take something very lightweight. VMs are going to be, I think, too heavy, and we're going to end up containerizing a lot of these things. So have any of you seen this memo from Steve Yegge? Yeah? A couple. Excellent. So Steve Yegge is an engineer at Google now. He used to be at Amazon, and he passed on the story that was designed to go just internally to Google employees about how Amazon changed and how their structure enabled them to innovate so quickly. So they're one of the only companies I've ever seen that their product pace continues to accelerate as they grow. Right? They're not held back by bureaucracy in the way that most large organizations are. And in this memo, what he said, he claimed Bezos dictated from on high that every transfer of information between different teams must happen via an API. It has to be an automated process. And that goes back to the Conway's Law discussion from earlier about if you separate things at the technological level and separate things at the team level, that's going to change the way you build your applications. And it also, what used to happen was you'd email somebody, try and get some data, they'd be on vacation, 2 weeks later they get back. That's 2 weeks that you couldn't have been building the application, 2 weeks that you can't be delivering value. And so the automation on the back end that moved to sort of a service-oriented architecture, or now we call it microservices architecture with less XML and less monoliths, is what enabled them to move so quickly. And so this is where microservices start to come back to that business value discussion of why should you do this stuff? Because it enables each of those groups to be much more agile internally without relying on external dependencies to get on with their job. Here's another example out of Guilt Group. They reorganized to do a microservices style approach. They reorganized in a way that I would describe as the cultural aspect of DevOps, in that they used to have a big EA team. They trashed it. They moved all those people down to the individual org teams so that they could collaborate more closely and be a lot more agile about the way they were doing architecture. Now the question is, how are people building these microservices? Because this is such a new idea. Like I said, it's come out of almost nowhere in the past year, that the path from here to there is very unclear. And so what we've started seeing emerge is a number of different open source projects and services that help people basically think about a microservices SDK, if you will. Capgemini's Apollo and Mantle, which is out of Cisco's Meta Cloud group, are probably the best examples of this. They build on top of tools like Mesos, like Terraform, like Packer, to give you a data center-like operating system, right, that lets you deploy these services at scale without, again, worrying about individual resources. And you would imagine that within all of those containers, you would do some kind of automation on the container creation side, and that's where this infrastructure as code comes into it. And so this is the direction that I see things going. Now I just want to very briefly talk about a couple of examples. This one is no longer interesting because they come up on every talk you go to, and they're a unicorn, and the route from here to there for most IT shops is very unclear. When you're like, all right, they're a greenfield technology, they're all on a cloud, whatever. We're a little bit more pragmatic than that. Software AG, this is an old enough software vendor that they got the name software as their name. They've been around for a little while. They moved to a microservices infrastructure, not just internally for their integration paths, but they actually deployed it to a lot of POS systems, deployed it to a lot of kiosks, and had a lot of success being able to innovate more quickly because of it. Now here's a really interesting one. So there's this cab hailing startup called Halo, super popular over in the UK. You may not have heard of it over here. And what they saw, and I know you can't really read this graph, so I'm just going to quickly give you an overview. What they saw was that sort of vertical line in the middle you can barely see is when they flipped over to a microservices architecture. And the blue line on there is the total jobs completed. So they've got all these jobs coming in from cabs getting hailed. The red line is the cost per job. And what you can see is when they made that switch over, the number of jobs continued to increase and in fact accelerated its increase. Well, the cost per job dramatically decreased. So it was a lot cheaper because they got a lot better utilization out of more granular units that could use infrastructure in a very flexible way. And I'm not going to talk over this because I've only got a few seconds left, but here's one more example. And so as an overview, as I was talking earlier, what we're looking to do here is increase agility while minimizing risk. And here are a series of different approaches at various levels across the stack, some of which you probably do have empowerment over and some of which you may not, and that'll require you to collaborate. But then again, that's what DevOps is all about. And so talking to the development groups about what they're doing from a microservices level, from continuous integration level, talking to them about feature flags, and then talk to them about your side of it. What does that look like? What does continuous deployment look like for you? What does rolling updates look like for you? And every one of these things minimizes the impact of the risk. Finally, this is a chart I love to show. So there's this book called Leading Change by John Cotter, very well-known sort of business management consultant around change management. And he's got an 8-step process for how you make these changes. The thing that's really amusing to me about this 8-step process is that you're not actually doing anything until step 6. Everything before that is about building the momentum, building the cultural influence, building the executive buy-in to make the change happen. And so this isn't something you can do overnight. It's something that you have to start very slowly and generate the momentum before you can start making a win. And I guess what I want to end with is how the world is changing, what you can do about it. So how do you take this new approach? DevOps. What is the new approach? Microservices. And why should you do it? Survival. There's a friend of mine named Andrew Clay Schaefer, actually one of the co-founders of Puppet years ago. And one of the things he loves to say that I think about every single day is that it's not mandatory that your company survive. There's no requirement that you exist 2 years from now. The requirement is that you innovate faster than your competitors, and this is how you get there. And with that, I'd like to close, and I think we're probably out of time for questions, but we might have a couple of minutes. Thanks.